So here we are trying to set up this experiment to verify Newton's second law and third law. And again, we need the track set up as in the previous lab, and the track should be leveled. So I'm assuming that you've already done that. And then after that, you got to get this end stop, and you got to put it at the two ends. So let's try to put it in this end first. The nut has to go into that channel, which is kind of tricky, and then put it off a little bit so you have space for connecting the pulley later on. You know, this is the pulley that we're going to use, and we need to set this up at the end. Well, why don't we go ahead and do that? So get that pulley out and then connect it to the end. Right, so if it is like this, let's see if that way it will touch that. So let's put this way and move this to the center and tighten it to the end as I've done now. And then you can loosen this nut and bring it up. Because when we pass that string, we should make sure that the string is level. So you get that string that has been given to you, tie one end of the string to this mass hanger tightly, knot it many times here to make sure that it doesn't slip out. And then you have to pass the string, the other end of the string, through the hole in that end stop. Carefully pass it through that hole in the end stop, and the string passes over the pulley like that. Okay, and at the other end, before we go there, let me just use this to let me take a weight. And hopefully it'll stay there. I've just placed it there. Because there's another thing we got to do is, you've been given this rubber gasket and a hook. We got to get that hook out, and this hook needs to go into the end of the cart. If you have the magnet attached there, you got to remove that magnet just like I'm doing now. Take it off. We'll need that for other labs. And then see this, put it right there and tighten it. Do not over tighten it. And when it stops, that's it. So put that hook there. And I'm assuming that you have already charged the cart, because we need a charged cart, of course. And then take that other end of the string and tie it to the hook. Again, make sure that it's tightly tied to make sure that it doesn't come out of that. Another thing that you have to be very careful is about the string being horizontal. That means the gap here must be the same at the two ends. The gaps must be the same. It should be perfectly horizontal. So that's very important. And usually if you have the pulley all the way up like I did, it's going to be horizontal. And also make sure that the string is not touching any part of the stopper as it passes through the hole, which it should not. And so it's ready to move now, and we are set up to do the lab. Okay, so that's the setup for the lab. All right, now what we need to do is we need to connect this cart or rather the sensor in the cart to the software running on your laptop. Okay, so that's what we got to do now. So for that, you got to find where the icon of Pasco capstone is, click on that and open it like I've done now. So once that is open, make sure you go to the smart card and, well, turn on the power. When you turn on the power, you can see the lights blinking like I explained in the previous lab. And it's trying to make that Bluetooth connection. See, the Bluetooth is blinking red now. So in order to connect it, you go to hardware setup, click on that, and it's searching for wireless devices. And as soon as it gets the smart card, which is the blue one, of course, in this case, you see the 4 sensors coming up. All right, so in this lab, we need the force sensor and the position sensor. So we need not use the acceleration and the gyro sensor. So we turn them off. Now, hit the toggle switch and turn them off. So you have the smart card sensor, the position sensor and the force sensor turned on. Now you can hit the hardware setup again and that goes off. And you can directly go to, you can click on these graphs, or you can pull the graph from the right side. That's a second method. Or click on the sensor data, which is what I did now. Click on where it says sensor data, and immediately you have position and time. We need the velocity and time, so put the check mark on velocity and time. So on the y-axis we have velocity, and on the x-axis we have time. You know that the slope of a velocity time graph will give you the acceleration. So that's what we're trying to get from this graph. But we also need to measure the force, so we need another graph. We need the force time graph. Now, in order to do that, we can pull in another graph from there. You can go to workbook, add a page. You can do that. And then you can go back to where it says graph. Pull that, click and drag. You have the graph now coming up there. And you can select anything that you need. You can pick time on the x-axis, and then the measurement on the y-axis is going to be force. So now we have the force time graph as well. And you can set up these graphs side by side, or you can see them one by one. Like page 1 shows you that velocity time graph, and page 2 shows you the force time graph. You can set it up either way, but we need the 2 graphs. I'm going to have them set up differently now. I'm not saying both of them together. That's okay. So that is the primary setup. To do the lab, you actually need to pull this cart away from the pulley. I think that will do. Make sure that the pulley is not oscillating. You hear all these noises. Make sure that this is leveled. I think when I moved it, it went off level. So make sure it's leveled, like I told you in the last experiment, so it doesn't rattle like that. And right now, you got to have 20 grams at one end of that pulley, 20 to 30 grams, so which I did not do. So here I go. I'm just using 10 grams. Carefully take this and then place the 10 grams on that. You can do it with 10 grams or 20 or 30 grams. Just force enough to make this move. Make sure again that the pulley is not oscillating, and then keep the cables out. I have this microphone cable out now. Okay. And then you just let go of the cart and hit the record button. So try to do that simultaneously, or it's better if you just let go and then hit the record button immediately. And hit the stop. Now it's run into the stop, and that's why you see that kink there and it coming down. It's coming down, but we can avoid that totally. Okay, we can avoid that. So what we need to do is we need to first of all zoom in on that, and you can do this by clicking and dragging here on the x-axis when it becomes a double-headed arrow, as you can see, as you see me doing. And then if you see the hand symbol, you can move that down. So adjust it. Again, you can zoom in that way. There are several ways of zooming in, but I think this works. We need the straight line part of the graph. That's what we're looking for, because the slope of the velocity time graph gives you acceleration. Now, since we need only that part of the graph, we have to select that. For that, you go to the pencil icon with the 3 dots and then go click on that. You get this rectangle. Move that rectangle to the straight line part. Now, you got to have maximum number of data points, but you also got to make sure that it's in the straight line part. So I think that works. Maybe this. Okay. I got a few points, 5, 6 points. And then we need to find the slope. To find the slope, the best method is to go to the linear fit. And to get to the linear fit, you see you have the slope tool here. Do not use that. Instead, go to the fit. You see, there's a drop-down arrow there. Click on that, and you get a check mark. Or put a check mark rather where it says linear. Okay, so first of all, remember this is a switch. If it's not switched on, you won't see it. So see what I did? Make sure this is switched on, so it'll be grayed to show that it's on. And then go to the drop down arrow and, pick linear fit. And the M that you see there is the slope. So that way we get the slope, which is the acceleration, right? Next, let's go to the second graph and see what happened there. Let's click on this and go to velocity and see that comes up, and then go to force, and then you get it. So if the graph doesn't show up first on the force time graph, you can do what I did. Just pick velocity here on the y-axis, and then you see the velocity time graph again repeated here. And then you can change it to force when you get it. So in this case, the force is supposed to be a consistent one, a constant force. And that is what we're looking for. We need to see if this happens, if it just zooms in. Click on this, which says scale axis to show all data. Click on that, it'll come back, okay? Again, you can bring this down, and what we need to do is get this number as accurately as possible. Therefore, we're going to have to zoom in and see where that is. Or we can select the straight line part, which is kind of this area here, and try to pick the same points that we picked in the previous graph, which was up to here. Okay, or rather maybe here, we left out that point. And then you can go to the sigma, where it says sigma, look at that, and find the average value. Again, make sure it's turned on, and then there is already a check mark on the mean. So that gives me the mean value as 0.05 Newton. Let's see if we can zoom in a little bit more and get a more accurate value. No, I don't think so. So that gives 0.05 Newton as the force. So that is how you do this part of the lab. All right, remember to repeat the lab with masses of 250 gram and 500 gram on the cart. And when you do that, you would need more hanging mass to make it move with an appreciable acceleration. Okay, and then to get the theoretical value of acceleration, you use the lab document. Equation number 4 gives you the formula for calculated acceleration, which is m2g. M2 is the hanging mass, and M1 is the total mass of the cart and whatever you placed on it. So M1 and M2. And the formula is M2 by M1 plus M2 multiplied by G. So once you get the calculated acceleration, you can also calculate the force, which in this case is called the tension. And that is done by using equation number 3, which is simply multiply the calculated acceleration with the mass of the cart and whatever it's on it. That is M1 times A. M1 times A. Because that's the tension in the string connected to the cart, which is what we're trying to find, because that is what the force sensor in the cart measured. So now that you have the theoretical values and the experimental values, you're able to compare them. To remember to put those numbers and values carefully in the tables and check if Newton's second law has been proved. Now let's move on and do the third law. So if it has the magnetic stopper, you got to remove that magnetic stopper from there. And we have to attach the other hook. So the hook would be, again, get that hook and connect it. So once again, connect that hook to this cart. So now we have the two hooks, and we need to now find that spring, which we will use to verify the third law. So there is a box that says spring set on that. That is what we're going to use for this, the spring set. And do not take the smallest one. Please get a spring such as this and connect it to the two ends of that. So now we need to, remember to turn on the other cart. And it's the Bluetooth is blinking now. Go once again to the hardware setup, and you should see the red one come up right there. We do not actually need the position sensor in this case. Anyways, we don't need the gyro and the acceleration sensor. So turn those two off. You only need the force sensor this time. So the force sensor is there on both. Okay, hit the hardware setup again so we can see the graph. Now, another thing we need to do before we proceed is to see another graph. You can go to this vertical arrow with a flower symbol and click on that. What it does is it adds another y-axis to that. So there you go. So now I have force on the blue on the left side and force on the red on the right side. So blue and red. And so we're now ready to do this. So what we do is we take the spring and attach it to the two hooks. And all right, before that, we got to start recording, and then gently pull on this. It's still so, okay, gently pull on both of these. Like that, you see, and the graph continues. You can hit stop. And what we need to do is we need to find the values. So for that, we need the coordinates tool. This is the coordinates tool. Click on that. You can add coordinates. The first one, the coordinates tool will help you measure the force. So you can measure it at different points. Make sure you attach it to that point, which is at 5 seconds. It's reading 1.14. Now you can get the same value from the red one, 1.14 actually. Click on that red one and let's see if we can get another one. Okay, so that, and take it to the red graph, and at the same point read the force. It's only 0.79 newtons. Now don't worry about that because the sensors have not been corrected, that's why it's showing that. But you see that there is a consistent difference between the forces. So that is okay. So you can keep doing this for different points. You can pull this and take it to another point, and that's 1.48 for the blue. And likewise move this to the same time, and it's 1 Newton for the red. All right, now that we have done Newton's third law, which states that for every action there is an equal and opposite reaction. So that means the forces theoretically on the blue and the red cards were supposed to be equal. But you may find a little difference between them, and you have to calculate the percentage difference between the two forces. How do you do that? Take the difference between the forces divided by the average force of the two times 100. Difference between the forces divided by the average of the two forces multiplied by 100. This way we can check if we have proved Newton's third law. So that is how we do the lab on the verification of Newton's second and third laws. Thank you.